Welcome to the 5th Kibo Robot Programming Challenge, Kibo-RPC, the final round. Well, this year is remarkable since we have reached the 5th year of the Kibo-RPC. A record number of 2788 individuals of 611 teams from 13 countries, region, and organization. My name is Yayoi Miyagawa from JAXA. I'm a master of the ceremonies. First of all, let me introduce our commentators for the final round. Professor Shinichi Nakasuka cooperates with JAXA on promoting of autonomy and automation of Kibo module. He is also our advisor of Kibo Robot Programming Challenge. Nakasuka Sensei.
Hi, my name is Shinichi Nakasuka, the professor of the Department of Aeronautics and Astronautics, University of Tokyo. Today, I'm very happy to be a commentator. I'm looking forward to seeing the excellent behavior of your program.
Thank you, Professor Nakasuka. Another commentator is astronaut Norishige Kanai. Kanai-san, please.
Hello, my name is Norishige Kanai, one of JAXA astronauts. Since first time Kibo-RPC, JAXA astronauts have been participating in the event from onboard the space station as well as from the ground. This time, personally, I've never participated in the event, so I'm very happy finally to be a part of the event. And also, NASA astronaut Janet Epps supported this event from space station. She is one of my best friends and one of my classmates. So with her, I'm even happier with the event. Thank you very much.
Thank you, Kanai-san. It is great to hear that you're a friend with Janet. Okay, also we have some finalists here at Tsukuba Space Center. Okay, thank you. As you can see on the screen, this is today's overview of the event. We will introduce the Kibo Robot Programming Challenge, then a message from the NASA Astro-V team. Following that, introduction of the rules. Before the competition starts, NASA astronaut Janet Epps gives us pre-recorded opening remarks on board and introduction of the setup. Each team introduced themselves and watched the competition. We've had an onboard operation and recorded the Astro-V's flight operation ahead. Also, this is JAXA's drone robot Interpol 2, first time to join this competition to watch over. Each team had an opportunity to watch its flight. They do not yet know the score and the other team's flight. So it will be good for them to watch and see the result today. At the end of the competition, we will have an award ceremony. Then we have feedback from our advisor, Professor Nakasuka. Then closing remarks from NASA astronaut Janet Epps. Now, I'd like to introduce about the Kibo Robot Programming Challenge. The Kibo-RPC is a competition and an educational program in which students solve various problems by programming free-flying robots such as Astro-V and Interpol 2 in the International Space Station. This was the first joint appearance by Astro-V and Interpol 2 during the competition. This program is held under the cooperation of JAXA, NASA, and Asian Beneficial Collaboration through Kibo Utilization Initiative, Kibo-ABC. Students up to graduate school can participate in the Kibo-RPC. Because we consider nurturing teamwork, students need to form a team of more than 3 members to participate in this competition. This international competition is for students in Asia Pacific region and extended to the United States and the United Nations member countries. Each participating country, region, and organization held the preliminary round in June to July. The winning team of each preliminary round moved to the final round. Those first team had a chance to improve their programs to prepare for the final round. You will be the witness of this historical moment of who will be the winner of the 5th Kibo-RPC. Well, we have received a video message from Jonathan Barrow, Astronaut Project Manager, NASA Ames Research Center.
Greetings to all Kibo-RPC programmers wherever you are. I'm excited to welcome you to another year of Kibo-RPC. My name is Jonathan Barlow, and I am the project manager of the Astronaut Free-Flying Robot Program, which is the center of today's event. You should all be very proud of yourselves for having arrived at this point. As you can see, I'm here in the Astronaut Granite Lab. This is where a small team of engineers and operators test with code and hardware to make sure things are running smoothly before testing on the robots on ISS. We also use this lab to test improvements to the Astronaut localization and other changes to make the robot function even better. Astronaut robots have been floating around the ISS for 5 years, supporting various research and educational programs. But the Kibo-RPC program was the very first, and possibly favorite, user of the Astronaut robots. We are thrilled to be supporting this year's 5th annual Kibo-RPC. On behalf of everybody on the Astronaut team, we wish you all good luck today.
Thank you, Jonathan Tan, from Astronaut team at NASA Ames Research Center. It is an inspiring message for the students. Thanks to Astronaut team and their devotion and efforts, we can hold this great competition today. Now, we are going to move on to the explanation of the 5th Kibo-RPC game rules from Sayaka Umemura, a manager from JAXA. Following the introduction of the game rule, we'll watch the video on opening remarks given by NASA astronaut Janet Epps. Umemura-san, please.
Hi, I'm Sayaka Umemura of JAXA. I'm going to explain the game rule for the 5th Kibo-RPC final round. In the 5th Kibo-RPC, Astronaut is used as a programmable robot. Astronaut is NASA's free-flying robot in the ISS. Astronaut has a wide-angle camera called NavCam. Astronaut estimates self-position by using the NavCam and IMU. NavCam is also used for image recognition in this game. The participants created their programs to control Astronaut and compete for their programming skills. Here is a game story of 5th Kibo-RPC. One day in 2024, an astronaut on the ISS was busy preparing for a simple experiment program for the use of Asian Pacific region called Asian Tri-ZLZ. When the astronaut checked the required tools for the experiment, she found that some were missing. With a large amount of equipment on the ISS, searching for small items can be very time-consuming. There is no more time before the scheduled start time. It is almost time to start the experiment. Work with Astronaut to find the items she is looking for. Although this is fiction, it can really happen in the ISS. Participants are asked to develop a program to control the Astronaut and search for missing tools. We set the game rule based on this story. This is the overview of the final round. Every team already submitted their programs, and the programs have already been installed and completed running in the Astronaut onboard ISS. The program was run only once per team and scored based on several criteria. Now, let me talk about the objects used in this game. First of all, an Astrobee stays at the dock station in the beginning of the game. There are 4 areas that Astrobee should search for the missing tools. We call them lost items. In each area, the Astrobee should locate and memorize the type of items and number of them. Here, the lost items actually attached on the walls and ceilings of Kibo. Note that complexity of image recognition differs on each item. It means that the level of difficulties for image recognition is different. And the astronaut has a target item on her hand, which is what she is looking for. The game area also has a no entry area called the Keep Out Zone. The red boxes represent the Keep Out Zone, and Astrobee is not allowed to enter this area. In order to prevent Astrobee from crashing into walls, there are also Keep In Zone, where Astrobee can fly. Each team must move their Astrobee within the Keep In Zone, while avoiding the Keep Out Zone. Next, let's see the game flow. The game starts with Astrobee in this position. When the Astrobee is heading for a lost item, you can see it turns red. On the screen, you can see the image of Astrobee's camera called SciCam. Please note that SciCam is not the camera that is actually used for image recognition. It is NavCam. There are maybe some differences between what you see and what is scored as a result of image recognition. You see the difference of the locations of SciCam and NavCam. Needless to say, the closer to the object, the more different the field of view is. When image processing is done, you see a table on the upper right, which indicates the result and correct answers. When all items are red, Astrobee reports the astronaut that the rounding is completed. At that time, it reports her the locations of the items, and if they are correct, check marks are placed in the upper right table. Then, it reads the target item held by the astronaut. When reading is completed, it goes to the location that is identical to the target item. When it shoots a picture of the target item, it tells the astronaut that the mission is completed. To summarize the game rule, you need to report the correct item and its numbers in all areas. Correctly identify the target item the astronaut is looking for and report the location where you found it. Note that the full score is 270 points. Scores are allocated according to the difficulty level of image recognition. You have only 5 minutes to complete the mission. If you fail to report the completion of the rounding within the time limit, your score is considered invalid. There is no time bonus. The team that completes the mission faster will have an advantage in scoring. If the program gets stuck in the middle, it is disqualified. Here are the key points to achieve this mission. It is important to write robust programs that can handle random conditions. It is also important to have an efficient flight path to save time. Attitude, rotation, and waypoints are the points of consideration. In the fifth Kibo-RPC, accuracy and speed of image recognition is very important. The participants have two choices for image recognition methods: pattern matching and machine learning. Especially in the final round, participants must also consider about the differences between the simulation environment and the real environment. That's all for the game rules. Now, are you wondering which teams will win? Good luck to all attendees. Back to Miyagawa-san.
Thank you, Mimura-san. Now I would like to introduce the honorable finalists in running order. This year, some finalists participate in this competition on site, as you see at first, Tsukuba Space Center, and some are online. Here is a list of running order as you see on the screen. It is an alphabetical order. Well, it's about time. Are you ready for the competition? Let's watch an opening remarks from NASA astronaut Janet Epps.
Hello, Earth. I'm Jeanette Epps, a NASA astronaut on board the International Space Station. We are orbiting around the Earth at an altitude of about 400 kilometers. Now, I'm talking to you from the Japanese experiment module, Kibo. Welcome to the final round of the 5th Kibo Robot Programming Challenge. Thank all Kibo-RPC participants for your many applications. This year, a record number of 661 teams with 2,788 students from 35 countries and regions are participating. About 8,000 students have participated since 2020. In the 5th Kibo-RPC, participants were asked to compete how accurately and quickly their program could respond to random events using NASA's AstroBee. Also, a unique aspect of this year's competition is image recognition. This aspect makes this year's game rules so challenging. However, the finalists have made great scores in their preliminary rounds, which were carried out with simulators on the ground. I believe this program offers participants a unique, enriching experience that is highly valuable for their future endeavors. This mission won't be easy, but I hope you do the best and wishing you good luck. Also today, my colleague Inflection 2 is accompanying and watching over the competition with me. Scuba Station crew is ready for starting the competition.
Now, thank you so much for the opening remarks. Okay, it's time to move on to the competition. We will hear the team introduction from the leader of the team. Then we will count down together to start. Okay, the first team is Dream Rover from Australia. Lee-san, Lee-san, please introduce yourself.
Hello, we're the team Dream Rover from Australia, Chatswood. We have 6 members in this team: Annabelle in Year 9, Jimmy in Year 7, Joshua in Year 10, and Joycelyn in Year 10, William in Year 7, and myself. Our shared passion for STEM and technological future has brought this team together to work on this project. I'm Ethan Lee, the team leader of Dream Rover, and I would like to thank the International Space Station, JAXA, Australian Space Agency, One Giant Leap, and other organizers on behalf of the team for hosting this fun and challenging event and giving us a chance to participate. Thank you.
Okay, thank you, Dream Rover. Okay, let's count together from 5 and say go. Okay, are you ready? All right. Okay, here we go. 5, 4, 3, 2, 1.
1.
Go!
Go!
Okay, it start moving.
Yes, the flight is very steady.
Yeah, and it's now try to move just in front of the lost item 1 and change the attitude.
Yes, seems like this team is translating in rotation differently in a sequence.
Okay.
Very stable.
Oh, great.
Recognition complete.
Yes.
Successfully. Check. The item and the quantity.
And go to the second target. So this is the interval to camera. Oh.
Try to recognizing item 2.
Item 2. Oh.
Item is recognized, but number is wrong. Quantity is wrong.
Yeah. What happens? Okay, so now let's go to the lost item 3.
Again, the flight is very stable,
Yes.
but quantity
Again,
wrong,
the quantity is wrong. Yeah. You need to change the attitude and try to avoid a keep out zone and move just in front of the lost item 4 position. Yeah.
Here it's very stable. Checking. Okay.
Oh,
Another mistake. Quantity is not recognized correctly.
and now move in front of the astronaut and report. And then read the target and try to move to the target position.
Which is target number 2.
Number
on
2,
the
yes.
Seating.
Yes. Yeah, movement is very smooth.
Yes. Steady and smooth. Yes. Oh, time is up.
Time is up. Oh,
Almost. It's very close.
It was a stable flight. Unfortunately, Astro B could not find the target item, but well done.
Oh, it is unfortunate that the time's over. So, well, hopefully you'll try it next time. So, anyway, but it is good that at least you had one item that you recognized. So, hopefully I'll see you in the next year. Okay, the next team is Team Mukul from Bangladesh.
Hello, everyone.
Go ahead.
Hello, I'm Muhtasam Ridwan, the team leader of Team Mukul. I'm currently pursuing a degree in aeronautical engineering at Bangabandhu Sheikh Mujibur Rahman Aviation and Aerospace University. My teammates, Galib, Jihad, and Naeem, all are computer science students from Khulna University of Engineering and Technology. Participating in the Kibo Robot Programming Challenge was an exciting and educational experience for us, especially watching our code in action inside the International Space Station. Opportunities like this we don't get every day. It's a great motivation for us. We extend our thanks to JAXA for organizing this exciting event and STEMX 365 for their support in Bangladesh. Thank you.
Okay, thank you, Team Mukul. Okay, let's count down together from 5 and say go. Are you ready? Okay, Here we go. Okay, 5, 4, 2, 3, it's 2, 1, go!
okay. It gets started.
Yes. Oh, this time it's translating and rotating simultaneously.
Yeah.
It's very quick.
Simultaneously. Yeah, very quick, very fast. Yeah, the left image shown here is different from the camera used for the image recognition. So please be aware of that.
Okay, item 1 successfully captured.
Yes.
Oh, it's already item 2 complete with success-free.
So this now moves to the 3. Oh, very fast. Already recognize the item 3.
Yes, impressed.
And move to the item 4. I think image processing is very fast.
Yes, and the flight movement is also very efficient.
Yes, very good, very good. Oh, all the 4 items was recognized successfully.
Perfect.
And rounding complete. Congratulations, great.
I see blinking, so it's already leading completed.
And now it's try to move to the target 2, I hope.
Thinking. And flying toward the target 2, which is the correct one.
Oh, it seems to see the different direction.
Yeah,
Oh,
slightly
why?
different. Interesting.
Oh,
Couldn't find the correct one.
It was a stable flight. Unfortunately, Astro B could not find the target item, but well done.
Yes, the first part is very, very great, efficient.
yes, and it recognized all the 4 items correctly, but unfortunately it could not go to the target position.
Okay, good job, Team Mukul. It was great. But unfortunately, you missed the target, but it was good. Okay, the next team is Celestial Ravens from Japan. Fujita-san, please introduce yourself.
Hello, my name is Kazuki Fujita. We are the Celestial Ravens from Japan. It's a great honor to participate in this final event. Our team members, Maya Abe, Shunben Masaoka, and I have experience developing rovers or hybrid rocket in our university labs. And in Kibo-RPC, we took advantage of our practical programming skills and teamwork. At the final round, we learned a lot not only about image recognition and robot attitude control, but also about the difficulties of handling the differences between simulation and the real ISS environment. Thank you so much.
Thank you, Celestial Ravens. Okay, let's count together from 5 and say go. Okay, are you ready? All right. Okay. 5, 4, 3, 2, 1, go!
Okay, it started.
Smooth, right?
Yeah.
And again, turning and translating simultaneously. That's efficient.
Yeah, as I said before, the left camera is different from the camera used for the recognition. Oh my god. The
First item, recognition and counting the numbers, both are failed, unfortunately.
How about a second target?
Let's see.
Oh,
again,
again, it fails.
wrong item and numbers are wrong also.
Number 3.
But the flight itself is very smooth.
Yes. Oh yeah, this is the interval to camera. Yeah, it is a higher precision. Great, very beautiful.
And now checking number 4.
Number
I
4.
think. Oh, finally.
Finally,
got-
it recognized correctly.
Yes. 1 out of 4 correctly recognized.
And now try to make a final report to the astronaut.
I see the backlight is blinking. That means the recording complete. Reporting complete.
So it only recognized the target 4 and the what kind of movement it will make. I'm very much curious.
Okay, leading complete. So seems like the robot is going to target number 4.
4. That's the only one target which can be recognized correctly.
But unfortunately, that is a not correct one.
Not correct one. Yeah. Oh, mission failed.
But at least they completed all tasks required.
It was a stable flight, but unfortunately, Astro B could not find the target item, but very well done. Well done.
The movement was very good, but image processing was not so good.
Oh, it is unfortunate, but you did a good job though. Okay, the next team is Techwin from Malaysia. Holis-san, please introduce yourself.
All right, thank you. Hi everyone, my name is Holis Francis, the team leader of Malaysia team, Techwin. Currently pursuing master's degree in physics. We are all from University of North Malaysia, and we are super excited in Kibo-RPC around. Thank you.
Okay, thank you, Techwin. Okay, let's count down together from 5 and say go. Okay, here we go. Okay, 5, 4,
5, 4,
3,
3,
2, 1,
2,
go.
1.
Okay, it started.
It stopped, then start turning and translating
All together.
altogether. Yes.
And it comes to the in front of the lost item 1 area.
Recognizing. And it didn't recognize.
Oh, it did not recognize. No answer.
But apparently it captured the video view itself.
Yes, I think so. And now changing the attitude and moving toward the lost item 2. The movement is very smooth and effective and efficient. And the how will be the image recognition. Oh, again, it cannot recognize.
Yes, no recognition.
Lost item 3
as well.
Oh, again.
Seems like there is some problem inside the recognition system.
Maybe the image recognition capability cannot deal with a real-world problem. So again, inward to camera is very precise.
We'll see number 4.
Number 4. Okay.
Yes, definitely it's capturing the video itself, but didn't recognize.
Yes. Yeah, movement seems very fast.
Yes. Okay. Are they going to recognize the target, leading the target?
And I'm curious which target it will go to. Oh, mission failed at this point.
Yes, they didn't lead.
That was a great flight. It was very stable, but unfortunately, Astro B could not find the target. But very well done. Thank you for your time.
Very difficult. The flight was very good, but the recognition system seems like there are two separate challenges in one mission.
Yes, movement is very small.
Okay, good try though. Hopefully we'll see you in the next year. Okay, the next team is Team PGS from Nepal. Shashank-san, please introduce yourself.
Good morning from the land of Himalayas, Nepal. My name is Shashank Srinivapane and I'm honored to introduce our team, Team PGS representing Nepal in the 5th Kibo Robot Programming Challenge. Team PGS is a group of passionate and innovative individuals who came together with a shared vision to push the boundaries of robotics and programming. Our team has 5 talented members, each bringing unique strengths from diverse coding backgrounds. We are MSIT students of the Presidential Graduate School in Nepal. Our team members are myself, Sasank Srinopane, team leader, Atish Sakya, assistant team leader, Sanju Paudel, Gaman Aryal, and Gaurav Raut. Our supervisor is Dr. Suresh Pokhriyal, also our college IT director. NESARC has selected us, and our point of contact is Rubo Adhikari. We are excited to participate in this programming challenge. Thanks JAXA and NESARC. Thank you for this opportunity.
Thank Team PGS. Okay, let's count together from 5 and say go. Are you ready? Okay, here we go. 5, 4, 3, 2, 1, go!
Let's go.
Okay, it start moving.
Oh, this time it's translation only. Then I guess turning second.
It's attitude and the position change is being done differently, independently. Yes, and now we try to change the attitude to capture the image of lost item 1.
Here you go, checking first item.
Yes, how is the image processing? Oh, it cannot recognize the lost item 1.
We will see the second item.
Yeah, it moves to the lost item 2. Again, with not simultaneous translational and the attitude motion.
Yes. It's not efficient, but in a way, it's very precise.
Yes, it's very precise. But it takes time, so I'm wondering it can finish within the time limits. Moving toward lost item 2.
Okay, then turning toward the
a
item
little
2.
change of the attitude.
Okay, right, recognizing. Oh, this time it recognized the item, but the quantity was not correct.
Yeah. It seems that there are so many waypoints are set, and so that means secure, very much secure, moving. But the program should be something like a time.
We have only 5 minutes.
Yes. Oh.
Coming towards item 3.
But it takes very long time. And to change the attitude and delete the camera. Oh, at this time, time is up.
Unfortunately, Astro B ran out of time to find the target item. It was a great challenge, and keep up the great work and continue to challenge yourself. Thank you.
It was a nice try.
Nice try, yeah.
Yeah, it was good try though. Hopefully I'll see you in the next year too. Okay, the next team is Inflection Point from Philippines. John-san, please introduce yourself.
Okay, greetings to everyone. We are Team Inflection Point, and I am John Royet D. Samson, together with my teammates, Mr. Mark Andro Cabile, Mr. Amer Panginiban, Mr. Aaron Martinez, Mr. J. Howell de la Cruz, and lastly, Mr. John Benedict Lontok. And we are currently pursuing Bachelor of Science in Aerospace Engineering, and we are at our second year of our college journey. We are very grateful to be part of this event, and we hope that our efforts would be reflected while we watch this run. May we meet the expectations of everyone rooting for us. Thank you very much.
Okay, Thank you, Inflection Point. Okay, let's go. Let's count down together from 5 and say go. Okay. All right. Here we go. 5, 4, 3, 2, 1, go.
Okay, it's start moving.
Okay, this time turning and translating simultaneously.
Yeah.
Very quick.
Very quick, very quick.
Yeah, recognizing from a distance.
Yeah, from the distance, yes. That is, I think, a good strategy.
That makes the flight distance shorter.
Yeah.
And the recognition was perfect.
Perfect. And move to the second lost items. And again, it is a little, far,
yes.
little far, yeah.
Ooh,
Oh, great. Oh, it took both lost item 2 and 3.
Simultaneously.
Yeah.
And the recognition was correct.
So again, import to camera. Very beautiful.
Ooh, already recognized.
Oh, very fast.
Perfect.
Very fast. Oh, already move to the final position. And report and read the target item image.
Should be going to item 2
Yeah.
location.
So,
The camera is already pointing to the ceiling.
yeah.
Now searching for item 2.
Yeah. It does not change the attitude very much. So that also reduces the time.
Efficiency.
So how comes? Okay, it moved just in front of the target 2.
Yes, it is the one.
Oh, shooting the target items correctly. And finish. Wonderful. Wonderful. Mission complete.
That was a wonderful flight. Astro B found the target item. Awesome job, guys. Great job.
Yeah, it seems very good.
Congratulations.
I'm very happy to see your joy movement. Wonderful. But anyway, it was very, very good.
Very efficient.
Yeah, it was very smooth and quick. Okay, the next team is SST1 from Singapore. Tae Tian Chen-san, can you introduce yourself?
Hi, we are SST1 from Singapore, and we are a team of 15-year-olds, and we formed our team as we are all interested in both astronomy and coding. We also wanted to nurture our skills further through this competition. I'm Gabriel, and with me is Vimal. We also have 4 other members, James, Tian Cheng, Yao Xin, and Sean, who are unfortunately not able to attend. We would like to thank JAXA and NASA for hosting this competition. Thank you.
Okay, thank you, SST1. Okay, let's count together from 5 and say go, okay? Here we go. 5, 4, 3, 2, 1, go!
Okay, it start moving.
Going towards item 1.
Yeah, simultaneous movement of the attitude and the position.
Okay, and recognizing from a distance.
Mhm.
Unfortunately, the recognition was
Incorrect.
wrong. Incorrect. Moving towards item number 2. And the flight was very quick.
Yep.
Smooth. And again, the strategy is recognizing from a distance. Now turning.
Oh my God. Oh, what happened?
Unfortunately, Astro B could not fly well. Great challenge, but keep up the good work.
Oh.
It's very unfortunate.
Yeah. I'm wondering what may happen, and so please, analyze what happened and reflect that to the next mission.
Well, it is unfortunate that the program failure. Well, speaking of problem, Kanai-san, I think while you were in ISS, you encountered some problems. How did you deal with it?
You know what? That problems everywhere in the space station. So it's not the end of the world. So we try to manage how to recover from the failure or problems. That's the most important thing. So as Nakasuka Sensei mentioned, please analyze what happened and how to recover from this failure. So that's a key.
Okay, thank you, Kanai-san, for the really encouraging message. Okay, the next team is Chippy Chappa Chappa Dooby Dooby Dabba Dabba from Taiwan. Xu Lang-san, can you introduce yourself?
Hello everyone, my name is Xu Shilong, and I'm the team leader of Chippy Chappa Chappa Dooby Dooby Dabba Dabba from Taiwan. And I would like to introduce my team member, Chen Zhen, Yan Yongyu, and Wei Zhixiang. Also the team member online, Zhou Boyu, Qing Huaijun, Kang Hongming. We are really grateful for the opportunity to join this event. Regardless of the final outcome, this experience is truly precious and valuable for all of us. Thank you.
Thank you, Lan-san. Thank you, Chippy Chappa Chappa Dooby Dooby Dabba Dabba. Okay, let's count down together from 5 and say go. Okay, here we go. 5, 4, 3, 2, 1, go!
Okay. I'm very much impressed by the naming of the team.
That's a great name, yes.
Okay. Yeah, it's again the simultaneous movement of the attitude and the position. And move to the ross item 1 very quickly.
Yes.
Oh, yeah.
Oh, success.
Success.
Very good.
And move to the rost item 2.
Okay. Coming closer to the item 2 to recognize.
Oh,
it's 2 and 3 simultaneously.
2 and 3. But the rost item 3 incorrect. And move to the rost item 4. Oh, why
cross.
5? Why 5?
It's only 4.
Oh, yeah.
But the recognition, that's very difficult part.
Yes, but recognition is very good, but the number was different.
Right.
And it seems that the upside down, the camera is upside down.
Oh, that makes translation efficient.
Yes, that is one of the strategy. Which camera to use? And now it recognizes target 2, fortunately, so it can go to the target position. Move to the target item 2.
Yes.
Good.
Perfect.
Great. Wonderful.
Very nice.
That was a wonderful flight. Amazing. Astro B found the target item, and great job. Awesome job, guys. Thumbs up.
Okay, well, it's unfortunate that you couldn't read the whole thing, but at least you made a target. Okay, well, to prepare for the next team, I would like to ask Kanai-san a question.
Okay.
How did you like to be in space?
Oh, being in space, that's wonderful. Everything is floating, that's interesting. And as you see, now we have robots on board the space station and collaboratively working together with human astronauts and robots. And that's like a sci-fi movie or a sci-fi stories. So it was fun.
Well, thank you, Kanae-san. It's very interesting that I wish I could be there to see the sci-fi, in the real. Okay, anyway, the next team is ready. The next team is Astronaut from Thailand. Siatom Chiagai-san. Please introduce yourself.
Hello, we are Astronaut from Thailand. My name is Thanathorn Chaikayut, and with me are Chisom Patipong and Chiraphon Deson and Surit Viswakit. Our team name Astronaut comes from our love for nuts, and we took inspiration from the word astronaut and added our own twist to make Astronaut, which sounds similar to astronaut. We are truly honored to participate Kibo-RPC final round as a Thailand representative team. Thank you.
Okay, thank you, Astronaut. Okay, it's a kind of great name. Okay, let's count together from 5 and 6, okay? Okay, here we go. 5, 4, 3, 2, 1, go!
Okay, it got started.
Yes, this is not astronaut, it's an astronaut.
Not.
Smooth movement towards item 1. Oh, something is floating.
Oh, yeah, something. Maybe the attitude is a little different from the other teams. And the item 1 was successfully recognized and moved to the item 2. Very quick.
Yes.
How will that result? Oh,
Yes.
great.
2 and 3
Oh, 2 and 3.
And
Oh,
correctly.
wonderful.
That makes saving the time, quite some time.
Maybe the flight path is very short.
Yes.
Oh.
Recognition, perfect. So all 4 items are perfectly recognized. Item and numbers.
And report is complete. And reading the target. So maybe the time is very important, and how you can find a shortcut or efficient way to go to the target point. It's very quick. Change the attitude.
Yes. Oh, it's not a in
oh,
front, it's a diagonal.
wonderful. Great.
That was a wonderful flight. Astro B found the target item. Great job.
I'm very impressed. They are checking item from the angle. Angled.
Yeah. I think I know. They make a very good short test pass, and by using such kind of the long distance, capturing of the target or attitude control. I think it's a very, very efficient trajectory. So that makes the time very short.
Very nice.
It was very smooth and very nice and very quick. Okay, the next team is UFO from UAE. Mariam-san, please introduce yourself. We cannot hear you, unfortunately.
We are Team UFO, proudly representing the United Arab Emirates University. My name is Mariam Al-Kitbi. I'm team leader, and these are my teammates, Salah Al-Mazougi, Hamad Mohammed, Hussein Al-Imam, Abdulaziz Rabat, and IQ Najjar. We are truly grateful for this unique opportunity, and we are extremely excited to see our final result. Thank you.
Okay, thank you, Miriam Sam, and thank you, UFO team. You guys wearing a Kibo-RPC towel and also can badge. Okay, let's count together. Are you ready? Okay, 5, 4, 3, 2, 1, go!
Okay, I'm curious about a UFO named
It's
Okay.
identify the object, or they are trying to identify the object. Okay, item 1, smooth
Very
translation.
smooth, very smooth. Oh, something is floating behind.
That's a cable of the mic.
Mic, okay. So item 1 was successfully recognized.
Okay, so far so good.
Again, it worked to camera. And lost item 2.
Okay, this is the one.
Oh,
success.
Success. Great.
Now item 3.
Oh, it moves to the right direction.
Yeah,
I don't know why.
maybe try to go out of the keep out zone.
Okay, it's moved back to the
Yes.
lost item 3 position and capturing.
Okay, quantity. That was
Quantity.
difficult. Yes, difficult one. Target 3. Target 4. They are rotating the camera. Now capturing the item. Success.
It's success.
Very nice.
Yeah, great. So the 3 out of 4 is successfully recognized.
Yes, that's not bad.
And the level, target item 2 is already recognized, and so I hope that it can go to the target position.
So camera is pointing already to the ceiling.
Ceiling, yeah.
Searching for the item.
With the keep out zone and move just in front of the target items.
Oh, there you go. Perfect.
Okay, shooting is very good.
Mission complete. Very
Congratulations.
nice.
Great.
Yes.
Awesome flying, guys. Astro B found the target in time. So great job. Excellent work, guys.
Yeah, time is just before 5 minutes, so just in time.
Great.
Wonderful.
Okay, thank you. Well, it's kind of unfortunate to read. Could miss the one, but great job though. Okay, the next team is Orion 1 from UN USA team. Salmon-san, please introduce yourself.
Okay, hello everyone. We are Orion 1 from Yogyakarta State University, Indonesia. And as the UNOSA awardee, and I am Salman as a team leader. And this is our team, Matthew, Fikri, Miftah, and Intan. Thank you for JAXA and UNOSA for the opportunity. We are honored to be part of this journey as finalists in Kibo-RPC 5th edition. We hope everything goes smoothly and we can achieve the best result for our performance. Thank you.
Okay, thank you, Orion 1. Let's count down together from 5 and say go, okay? All right, 5, 4, 3, 2, 1, go!
Okay, it start moving.
Okay, the movement looks great.
So, it captured the lost item 1 and try to recognize.
It is taking time.
Yeah. So I'm wondering what they are doing. The image recognition takes so long time. Oh yeah, success-free.
But it was success, yes, very nice. Item number 2, the flight was very smooth, efficient. Oh, success.
Oh, very successful.
This time, very quick.
Very quick.
Number 3. Again, it takes some time.
Maybe so. I'm wondering it can finish within the time limits.
Maybe the video is too complicated for recognizing. Oh, now moving towards maybe item 4 or trying once again item 3.
Item 3. I think try to recognize item 3 from the different direction.
Oh, I see. Then it's in the view. That's very nice recovery.
Such kind of the contingency plan is very important in the real world.
Yes, indeed.
But it still takes long time.
Yes. We'll see if it's recognizable.
Oh yeah,
success.
Oh great.
Very nice, very nice.
Right.
Now 1, 2, 3 complete.
Yes.
Too much time.
Oh my god, time is up.
That is very
That was a very
reliable,
precise and stable flight, but unfortunately, Astro B took a little bit too much time. So great job though, but very well done.
Yeah, very stable and very secure pattern recognition was made.
Yes.
So I think in that point, I think it's very great.
Yes, I like this strategy. Very reliable, precise.
Well, it was kind of unfortunate that for time over. Okay, the next team is Team Salcedo from the USA. Aaron-san, please introduce yourself.
Hello, we're Team Salcedo, and this is our 3rd year competing and our 2nd year as finalists. I'm Aaron Cancevoy, the team leader, and I attend the Georgia Institute of Technology with 2 teammates, Lucas Paschke and Gabriel Ashkenazi. Our 3rd teammate, Justin Bonner, attends the University of Miami, and we're extremely grateful to represent the United States again, and we're excited to see our results. Thank you.
Okay, thank you, Team Salcedo. It's kind of 2nd year, so I'm glad to see you guys again. Okay, let's count down together from 5 and say go. Okay, all right. Okay, here we go. 5, 4, 3, 2, 1, go.
Okay, start moving. Very smooth movement.
Yes. And recognizing from a distance.
Oh yeah.
That's a good strategy.
Yeah, with different attitude.
Oh yes, not perfectly in front.
Yes.
A little bit angled, but that makes saving some time.
Yes. Something like a shortcut.
Yes. Very smart.
What is the second target?
That's the 3rd target in the view.
Oh, we tried to recognize.
The 3rd one is correct, but the 2nd item was not correct.
two targets at the same time, that makes system complicated.
Yes.
Item 4 do not recognize.
So 2 out of 4 they can correctly recognize and report.
Not bad though. I see blinking. The light is blinking. That means recognized, reported, and leading the target.
So I'm curious to which direction it moves to, because item 2 was not recognized correctly.
It's like going to the ceiling.
The Astronaut is wondering.
Yes.
Where to go?
Going towards item number 2, possibly. Almost.
Oh, it goes to target now.
Oh, very good. Oh, time is up.
Time is up.
That was close enough.
Almost.
Yes, it's target.
It was a wonderful flight, guys. Amazing work. Astro B found the target. Great job.
Yes, Astro B found the target, but a little bit out of the time. Out of the time.
Maybe several seconds.
Yes.
But I'm wondering why it goes to the target number 2, correct one, even if they do not recognize it correctly. It's very interesting.
Yes.
Well, it's kind of unfortunate that the time's up. So hopefully I'll see you in the next year for the next try. So, well, anyway, we're going to move on to the... okay. All right. We'll have to wait for the next team is still preparing. So I think I want to ask you, Kanai-san, for a question. Okay, when you were in ISS, what is the hardest thing that you encountered?
Hardest thing?
Hi.
Everything is hard in a sense in space. But international cooperation, that's a challenge. Differences of background, language and cultures, specialties, but all together we somehow manage the differences and working together for the same goal. That's the biggest challenge. But at the same time, it was very rewardful, and that makes us working together in harmony.
Thank you, Kanai-san. Yeah, it is very important to work in harmony, especially like in a small space. It's kind of hard to, you have to really be careful with the human relationships. Okay. All right. The next team is Pho Vietnam from the Vietnam. Nguyen-san, please introduce yourself.
Hello, everyone. Hello, Professor Shinichi Nakasuka. We are Pho Vietnam. First of all, I want to thank our guidance professor, Professor Phạm Văn Bạch Ngọc, and our POC, Mr. Phạm Hồng Quân from the Space Technology Institute. Then I want to thank the Secretariat, especially Mr. Kohei Ako. I think Astronaut and Info are very interesting projects, and I hope it will develop further in the future. Thank you.
Thank you for Vietnam. I really enjoy your comments and very nice to have those comments. Okay, let's count together from 5 and 6. Okay, are you ready? Okay, 5, 4, 3, 2, 1, go!
Okay, it got started. Yeah, simultaneous movement.
And smooth.
Mm-hmm.
Recognizing from a distance.
Mm-hmm.
That's one very good strategy. But recognition was not correct.
Yes, so taking the image from the far distance may result in such kind of the misrecognition.
I see. If it's close enough, then it recognizes easier.
Yeah, I think so. So it's a trade-off. How about lost item 2? Oh, again, it could not recognize.
Missed. Number 3.
Oh, again.
Not recognized. Yes. Not only this team, but some teams have difficulty of recognizing the items and the numbers.
Mm-hmm.
That's a difficult part.
Yeah. How about item 4?
We'll see.
Oh,
what happened? Program failure.
Unfortunately, Astro B could not find the target item, and this was unfortunate, but it was a great challenge. So great job. Keep up the good work, and maybe next time. Thank you.
Nice work.
Yeah. 2 teams, hung up at, through the movement. But I'm wondering that it may result in some infinite loop or something.
It is unfortunate that the Astro V program was failed and couldn't recognize the image. It seems like the image recognition program is very difficult to build. So I think I really admire all the teams that you try that kind of things. And I think I cannot do that kind of thing. So I really admire you all. And we are actually, so hopefully I will see the Vietnam team again in the next year. And it seems like all the teams have been finished, but we are still kind of preparing, so I'm gonna talk a little bit some more. Okay, this is interval 2 in grand model, and so you see, you saw the interval 2 on a little bit on the far side at the competition. And then so anyway, so I would like to ask Kanai-san again for other question. Okay, so while you were in ISS, what is your what do you do in the pastime?
Pastime. The best way to spend pastime is watching Earth from the cupola window, and the Earth is always changing. The planet Earth is blue. Sometimes it's gray when we flying over the Sahara Desert, for example, or sometimes flying over the Himalayan very sharp high mountains. So it's always different, and that makes astronauts very relaxed. And yes, taking picture, another hobby for astronauts.
Wow, that really sounds great. I hope I could see the Earth from the space. It's really amazing to see that kind of thing. And have you seen any aurora from the space?
Oh yes, we are flying up close to the pole, so there sometimes we can see aurora above, not above, but under us. So that's a wonderful experience, and somehow it's very interesting experience.
Wow, I'm so jealous. And then, so how about like, have you seen any like a typhoon or those like weather changes on Earth?
Yes, the Mother Nature is another great spectacle to see from above and from space. So we could see a typhoon or hurricane, or we could see thunderstorm, and the lightnings are very beautiful, like the small, how do I say, small, like a fireworks under the cloud. It was beautiful from above from the space, but of course on the ground it's very scary. I don't like thunderstorm.
Yeah, that's great though. Like I've seen on the picture of like typhoons and all the clouds and then thunders from the space. And then, so you said that you like to take pictures, right?
Yes.
So what do you like to take picture of, especially like when you are in space?
I like more. I like cities. Because from space, even from the space, in the nighttime, we could see the lights on the towns, cities, big cities like Tokyo, New York, and Houston, maybe. Then we could recognize, oh, there's a town or there's people living on the surface of the Earth. That's another impression about the Earth. We are not, the nature is great, but also people are living, and we could see the way people living on the Earth. That's the beauty.
Wow, thank you so much. It's really like fun to see like night view, and it must be hard to take pictures at night view. But anyway, it seems like the setup is ready. So, we're going to move on to the next one. It seems like all teams have finished their run now. So, time to see who will win the honorable fifth year of the Kibo-RPC. JAXA astronaut Kanai-san will present the top 3 winners. Kanai-san, are you ready?
All right, I'm ready. Thank you very much, Miyagawa-san, and thank you very much for your questions. My answer was not very well prepared, but at least the students are ready, well prepared, so I'm happy. And I'd like to present the top 3 winners, and these winners are based on the scores calculated based on the time and also image recognitions. And I have 3 envelopes here. So in the envelopes there's the names of team. So in the beginning I'm gonna start from 3rd place winner, if you are okay. We'll see. So 3rd place winner will be okay, 3rd place, Team Mukul from Bangladesh. Congratulations. Very nice, very nice. This is your certificate for you. I will present for you from the distance, remotely. Yes, I'm very impressed. You guys unfortunately did not recognize on the second part, but overall you completed all the tasks, and that's great. And it was. By the way, your score is 193.52 out of 270, so that's a very high score. And because your flight was very efficient, so that makes gave you a bonus point. So that makes you a 3rd place. So it was great. So anything else? Well, we will later we will have some feedback discussion in the afternoon, and Professor Nakasuka and I will join. And I want to
hear from you about the challenges and also why you got such an efficient flight in the mission. So please consider how to recognize how to analyze your software and operations. And seems like second place is ready, so I will open the second place. Who will win the second place? Let's see. Second winner will be this is Flexion Point from Philippines. Congratulations. Congratulations. Okay, you guys are from remote, so I will present certificate remotely, but we will send you certificate. Okay, you guys got 250.88, so out of 270, so almost perfect. And I remember the flight was perfect and efficient, and you got all items and the final items together. So it was great. I really impressed. Thank you. Congratulations. And the final envelope is for first place. The first place winner will be Astronaut from Thailand. Congratulations. Yes. Please come here. Yes, I remember your team also successfully completed the mission perfectly. Congratulations. This is for first place. Congratulations. Have a picture together, please. A little bit closer, please. Very nice, very nice. Congratulations. Well, their score is 253.09. Excellent job. Almost 3 points, only 3 points above the second winners. So that's very close, but still it was great. So I'd like to hear some comments from leader, please. How do you feel about the first place and after finishing all the mission?
We are incredibly grateful to receive the first place. And thank you for the opportunity to run our course in the IAS. And we overcame many challenges along the way and prepared multiple backup plans to make this possible. So thank you for the opportunity to be part of this amazing experience. Thank you.
Very nice. Thank you very much. Okay, that concludes the final presentation. But I was very happy to see all hard works from all teams. And yes, some teams are maybe not met their own expectations. But in a sense, the teamwork is key, and that's the goal. So all your effort, time spent for this mission and endeavor will not be wasted. So in the end, in the future, these efforts will come back in a positive way. So thank you very much for your hard work, and we will see you possibly next year for the number 6 Kibo-RPC. Thank you. And back to you, Miyagawa-san.
Thank you, Kanai-san, for the presentation. And Astronaut, congratulations again. And now we'd like to hear the feedback from our advisor, Professor Shinichi Nakasuka. Nakasuka sensei, please.
Hi, okay. So, it was a very, very, very interesting and very great event. I was very excited to watch the behavior of each team. And I enjoyed it very much. Thank you very much for your great effort. So please give them a big hand. So through seeing their behavior, I found that there are many, design freedom or something like options for determining the behavior of the robot, such as, for example, waypoint selection, simultaneous or independent movement of attitude and position, and the camera distance when taking image, and image recognition algorithm, and the time management to complete the tasks within 5 minutes. The high score teams seem to select options appropriately. So let us see the scores of the teams. Please show the scores. So these are the scores. Okay, green part is perfect, 4x4, or target recognition was okay. Okay. So the top 2 teams got almost full score. Excellent, wonderful. Only the small difference is time. Each team already made excellent strategy to shortcut the trajectory between the areas to reduce the time. But Thailand is a little better than Philippines, but the difference is very small. As to the image processing, many teams seem to utilize AI technology such as deep learning and so on, and such teams' performance is better than pattern matching or other conventional algorithms. Some teams which obtained almost perfect scores in simulation round, that is a qualification round, could not get good result in the real world. Please consider what happened. This is coming from the difference of environment between the simulation world and real world, such as lighting condition and so on. Some teams try to recognize target 2 and 3 simultaneously. That is a very, very good strategy. But in order to do that, maybe the camera distance should be a little far away from the target. And that result in the reduction of the probability of the recognition correctly. So this kind of the trade-off should be solved appropriately. In this way, there are many design freedoms. And then how you can select appropriate options, that is very important. The key strategy is to iterate simulations with different options or settings many times and try to find the optimal setting. The winner, Thailand team, already tried, I heard that already tried near 1,000 simulation runs. Is it right? Yeah, they say they're right. Yeah, near 1,000 is very much, one done. And that is very important to tune the strategy. Okay. Anyway, I believe the participating teams in the final round obtained many lessons learned in the real-world experiment. I hope you will use this experience toward your future. In the next year, we will prepare the new game story. Very interesting and very difficult. Okay? And I'd like you to join us again. Anyway, thank you very much and congratulations. Thank you. Now, back to you, Miyaga-san.
Thank you, Professor Nakasuka, for the feedback. It was really interesting analysis. And now we are going to move on to the closing remarks from astronaut Janet Ives.
Well, this concludes the 5th Kibo-RPC final round on the ISS. Once again, thank you for your participation. I want to express my respect to all of you who worked on this program without giving up to the very end. For future Kibo-RPC events, we're considering using the JAXA INTBAW 2, which is now operational on the ISS. I hope that you will continue to take on various challenges. We look forward to working with you in space development field in the future.
Thank you, Janet, for the closing remarks. It is almost the end of the 5th Kibo-RPC. I think everyone did a great job. I'm so impressed that all you spent so much time and energy and effort to make things possible that you won the preliminary round to be a representative. Regardless of the result, you are all great and great challengers and winners. I'm proud of you. Be proud of yourself. Please consider challenging the 6th Kibo-RPC next year. Applications will be open in February 2025. The preliminary round will be next June to July timeframe. Now we conclude the 5th Kibo Robot Programming Challenge, the final round event. Thank you for watching and see you in the next year.